Welcome, class. Welcome to the Chapter 14 review. What I've done is I've taken smaller portions of Chapter 14 and broken them into several little chunks, and that's what we're going to be doing today, is going through each of those little chunks. The first part is really introductory in nature, and we're going to be taking a look at the different types of renewable sources, and then also take a look just very briefly about how we can basically put solar energy to work for us. So let's go ahead and get started. There are four things I want to make sure that we cover in the introduction today. First of all, how can we put solar energy to work for us? What are some of the hurdles we need to overcome, and what are the equipment and also techniques that are used to get solar energy from the sun, obviously, convert that solar energy or the photons that hit us into chemical and also electrical energy. The second part to this is we're going to be looking at some of the indirect sources of solar energy. Now, we all know that the solar energy comes directly from the sun, and the photovoltaic cells are just one way in which we can capture it directly. But we also capture renewable energy indirectly from the sun. For instance, wind energy, because of the forces that play between the temperature gradients from the ocean and land, that creates wind effects. So we can look at wind power. Also, hydroelectricity is another indirect one, as is the biomass piece as well. So we'll be looking at those kinds of technologies and how we can capture energy from them as well. And then lastly, we're going to be looking at some additional renewable energy, some alternative, if you will. Fuel cell technology is one that comes to mind, as well as biomass and wind and tidal energy. So those are some of the concepts we're going to be looking at a little bit later on. But let's go ahead and look at this pie chart. This pie chart is really kind of self-explanatory, but let me go ahead and just break it down for us. This particular pie chart only represents 6% of the total energy used in the United States, and that 6% of the 100% is really just renewable energy. So the other 94% represents fossil fuels. So we have a long way to go before we can actually start cutting into our dependence on fossil fuels. So if we take a look at this in particular, we'll notice that there are two big pieces of the pie. One of them is hydropower. This is an indirect source of solar energy, and it obviously is capturing some of the fresh waters and putting them behind a dam, and then letting them, of course, course through the spillways and other things, and actually spinning turbines. And those turbines are creating energy. In particular, in the West, most of our energy comes from that. But from state to state, if we total up all the sources that use hydro in the United States, about 45%. And surprising to me was this second part. Another 45% or so had to do with biomass. Now, the biomass plants that we have across the United States has actually really grown over the last few years, and that's why it now represents about 45%. Now, what's really interesting to me when we look at this is basically the remaining 10%. And that remaining 10%, if you take a look down here, we have, of course, solar representing about a little over 1%, and same with wind. These two are kind of fighting it out for third and fourth place, kind of, not third and fourth place, but they're very, very similar in the amount of the energy that's used. So there's a lot of room for growth there. But really what comes in third place is geothermal. Geothermal, I didn't realize that the United States uses about, of all of its total renewable energy, is 5% in geothermal. Geothermal is kind of cool because there isn't any intermediate time that it goes off. It is continual, it's very accessible, and I think we're going to see really big things for geothermal as time goes on. When we take a look at the total package, though, as far as total amount of energy, it's 5.9 quadrillion BTU units. And even though that sounds like a lot, it's only represents about 6%. So when we're taking a look at this particular this pie chart, remember we're going to be looking at all of these different types, but in particular we're looking at geothermal, solar, and wind because that shows the greatest room for growth. So we'll be looking at that in just a moment. Now here's all the different kinds. So if you take a look at this particular chart, you notice at the very, very top, which is right here, this happens to be direct solar energy. For instance, like space heating and heating water and those kinds of things. We also have photovoltaic cells and arrays. They're kind of all over the place in the West and in particular Southwest, where there's obviously a lot of sun. And then we also have things like solar trough collectors. Those are typically in desert regions because they need a lot of space, but they need to be close enough to transmission lines so they can get some of that energy out to other locations. We also have this second tier, and these are some of the indirect sources. We've talked about one of them, that being wind power. When we have all of these wind farms all across the United States, one of the things that strikes a lot of people is that their immense size. A lot of them are now over 100 meters or about 300 feet tall. And of course, you have 15, 20, 30, 40, 60 of them. And one might have been kind of aesthetically pleasing, but all of a sudden now, with dozens of them in any one location, we have some problems that we have to deal with. And then, of course, when we look at solar, indirect solar, we're also talking about water power and hydroelectricity. How solar is indirectly related is because it's, of course, part of the water cycle, and all of that falling water from gravity can spin turbines, and then, of course, generate electricity. And then we look at hydrogen. Hydrogen also, because it's kind of water related, it is also indirectly solar. And then when we get to the bottom of this, we have bioconversion. And that's also indirectly solar, by the way. As the sun grows, the plants like forests, we can harvest the fuel wood, and of course then there's trash, and we can burn it, and also agricultural waste, we can burn that into cogeneration plants or biomass plants. And then also here in California, we have biodigesters in a lot of the dairies. And when we go to some of the dairies, especially in the San Joaquin region, they are capturing the manure, generating, of course, methane, and the methane then is being burned to turn into steam, to heat water, of course, to turn the turbines that will create electricity. And then, of course, in the Midwest, we have, of course, a generation of corn, which is distilled to make ethanol that can be mixed into gas, and then, of course, create biodiesel. So we have a lot of those kinds of alternative energy we need to look at as far as how we're going to replace fossil fuels. I really don't think there's a kind of one silver bullet, if you will. I think what we're going to have to kind of settle with is a lot of different things, regionalized, local, as well as, of course, the United States, as well as across the nation, across the world. I think each region is going to kind of bring some of its best technologies to the forefront. And then lastly, what I want to show you is, of course, some of the alternative methods, things like tidal power, things like more geothermal, and then, of course, they're looking at other technologies in the ocean to make things happen. So those are just some of the examples of renewable energy sources. So when you think of renewable, it's just not always solar. There's a variety of other things that hold a lot of promise for us in replacing fossil fuels. Now, one of the things, probably the most, I guess, popular, at least in the news anyway, renewable energy sources is solar. And one of the things that we have to kind of consider is how are we going to get that to work for us? Because there are some kind of barriers you need to overcome when you take a look at solar. First of all, they're relatively costly. And although just a few years ago, the amount of time it would cost you to pay off your initial investment was 20 to 25 years. That now has dropped down to about 17 to 18 years to pay off the initial investment that you put in. Getting around 10 or 12 is kind of our next level, next hurdle we need to look at. But if you take a look at solar, it requires a few things, like for instance, a structure support some of the mass, because these photovoltaic cells right here are not light. They're relatively bulky and not very flexible, so they do a good job, but they definitely need some support underneath them, and they can become heavy. In addition to that, they have other systems that need to be put in place, like inverters and other things that will convert the energy that we need. Also, there's storage batteries involved in it. So there's a lot of things in this solar energy game that we have to consider. They've come a long way. I mean, we're going to be seeing a movie about nanotechnology, how nanotechnology and some manufacturing techniques have been applied to photovoltaics. So now it's barely condensed down to a very thin film. And in that thin film is all the components that are now in a large PV cell or photovoltaic cell. So we have kind of miniaturized all of that down so that you could just roll it out on your roof or roll it out on the wall. There's even been some experiments done that they're actually putting some of the photovoltaic types of energy capture systems into paint. So you can paint it on a wall and it'll generate electricity. So those are some exciting new things that are coming up that will make solar work for us. So it's important to know that even though there's PV cells, not in the next 5 to 7 years, we're going to see some very interesting types of photovoltaic cells that basically roll onto your roof. Now, in order to put solar to work for us, there are some things I would like to share with you as we kind of go on. And one of the things that we have to understand before we understand how to put solar to work for us is we got to understand the principles of solar energy. So we're going to be looking at what really makes solar energy. Well, solar energy. By understanding how the photons get from the sun to here and how they behave within our atmosphere, it is really important to develop good technologies and also kind of go to the next level in terms of generating that new technology. Secondly, we're also going to be taking a look at how solar is used to heat water, because the heating of the water is kind of the point for most solar systems, because you want to heat up water to be able to create steam, to turn a turbine, which turns inside of a generator, which creates electricity. So by understanding how solar energy impacts the heating of water, it's just one of the steps to understand how the entire system works. The other component that we're going to be looking at in a few minutes and today is solar space heating passively. How can you get the solar energy to be more passive? Because when it's a passive system, it's cheaper, it's easier to maintain, and for the most part, it can help lower some of the costs. So it's relatively efficient. So we're going to be taking a look at the different kinds of space heating technologies, and not only systems, but in particular how it works. And then the other thing we're going to be looking at and talking about is solar production of electricity. Okay, once we understand the principles, once we understand some of the techniques and the machinery that goes behind it, we need to also take a look at, all right, we got all those pieces and parts together. Now, how do we put it together to make electricity? So that's really kind of talking about systems and putting those systems together to make electricity work. For instance, we have photovoltaic cells, and of course, how does that make electricity? What is some of the physics behind it? We have solar troughs. How does that work? And near the end of chapter 14, we'll be looking at that as well. And then lastly, what's the future hold for us as far as solar energy? What's the promise? Where's the payoff? Not only is it going to reduce our dependence on foreign oil and lower our carbon footprint, but also, from a practical sense, how's that efficiency going to kind of make it pay for us, if you know what I mean? So it's not always about the warm and fuzzy, it's also about the practical. So we're going to end it right here for now. This is the end of the first part. We're next going to be going to some of the principles behind solar energy, and so that you can understand a little bit about how to capture that energy and convert it into electricity. So we'll see you in a few minutes. So hopefully you'll get something out of that film as well. All righty, see you later. Bye.